Okay folks, hope you've had a good Easter. We're going to start chapter 3 and we're looking to complete this in the next 3 weeks. The first part of it is on arithmetic sequences and series. Okay, so let's get some definitions out of the way first. The first word I should really define is sequence. A sequence is something we've encountered in GCSE and it just means a list of numbers that follows some sort of rule. So if we look at our first sequence here, the list goes 5, 9, 13, 17 and the rule for them is plus 4. It is always the case that to get the next term in the sequence you add 4. For our second one here, the rule is take away 3.4 and again that's the same all the way through. The word arithmetic means that the rule that you use is a plus or a subtract of a constant amount. In other words, we say this has got a constant difference between the terms. So both of these are arithmetic sequences because the rule is always to plus or subtract the same amount each time. We use D to stand for this constant difference, so we could quite as well say for this first sequence that D is 4 because we are always adding 4. Or for the second one we could say D is minus 3.4. We use A to stand for the first term in a sequence. So in this first one we could say A is 5, in the second one we could say A is 17. And we use N to stand for a position within a sequence. So I could look at this number 17 and I could say, well, that's the fourth number in the sequence, so that's where N equals 4. Or I could look at this 13.6 and I could say that's the second term, so N equals 2. So once we've got A, N and D defined, we can put them together into a formula to give us an nth term of an arithmetic sequence. Now this is exactly the same formula that you used in GCSE, we just get to it in a slightly different way, but it will give you the same results as before where we just maybe found the difference and then found the zero term and slapped them together. We're trying to be a little bit more precise now. So the formula here is that UN is A plus N minus 1D, and UN in general stands for the nth term of a sequence, not just with arithmetic but across the board. So let's say if we wanted to use this for our sequence here, we've got 23, 19, 15. Let's go through the list and see what we know. We know that A is 23 because the first term of the sequence is 23. We can have a look at what the difference between the terms are here, which is minus 4. It's going down in 4s. So D is minus 4. So if you want to find the nth term here, we would say that UN is equal to A, so 23, plus N minus 1, because we don't know what N is because that depends where you are, and then D is minus 4. We can simplify that if we want. We can say this is 23 and then times that by minus 4, so 23 minus 4n plus 4, and we can simplify that even more and say this is 27 minus 4n. Now you could have done that I think with GCSE techniques. You know it's going down in 4s, so you know it's going to be a minus 4n, and then you like go back a term and say, well, this is 27 here, so it's 27 minus 4n. This is just trying to make this a little bit more precise. Okay, so follow-up questions we could ask here. Find the 48th term of this sequence. Well, if we want to find the 48th term, that's when n is equal to 48. So we plug that into our formula. We would go that, okay, so the 48th term, which we can write as U48, is equal to 27 minus 4 times 48. In other words, they're 27 minus 192, which is minus 165. Okay, excellent. Lastly, find which term is equal to minus 65. So we're not finding the 65th term or anything. We're saying here that the nth term is equal to minus 65. So putting that together, we'd say 27 minus 4n, because that's our nth term, equals minus 65. And then we'd swap over the 4n to this side. We'd swap over the 65 to the other. So we get that 4n is equal to 92. And then we can divide that down by 4 and get that n is equal to 23. So it's the 23rd term, which is equal to minus 65. Okay, let's look at a slightly more exam version of this sort of question then. It tells us we have a formula, which is in the form an plus b. It tells us that u7 is 12, so that's the 7th term is 12, and it tells us that U29 is 67, so the 29th term is 67, and it wants us to find A and B. So what we want to do is look at our nth term formula to start with. So we're going to ignore that one up in the top right because that's slightly different to what we've been using. We're going to write out that UN is equal to A plus n minus 1 lots of D. And then we're going to write down two statements based on the two statements they've given us. They told us that U7 was equal to 12. So let's do that first. Let's sub in that n is 7. So that'll give us U7 is A plus 6D, because obviously 7 minus 1 is that. And we know that's equal to 12. And U29 is equal to A plus 28D, which is equal to 67. Now what you essentially have there is a simultaneous equation in terms of A and D. And what we want to do is move around with those and find out what A and D actually are. So if we subtract the top one from the bottom one, we'll end up with 22D. And if we do 67 minus 12, we'll end up with 55. We can then divide that through by 22, and we can get that D is equal to 2.5. And then we could plug that back into one of the other formulas. So let's plug it back into U7. U7 is equal to A plus 15, which is equal to 12. So that would tell us that A is equal to 12 minus 15, which is equal to minus 3. So let's go back to the actual question now. An arithmetic series has this formula, and we want to find what that formula is. So again, the nth term is A plus n minus 1D. We know that A is minus 3, so we can sub that in. And we know that D is 2.5, so we can sub that in as well. Now, that's not quite in the form that the question has given us. It wants us to be an plus b of some sort. So we need to rearrange this, expand out the brackets. That'll give us 2.5n minus 2.5. And then we can collect together our constant terms, and we can end up with 2.5n minus 5.5 as our final answer. So to actually answer the question, their A is equal to 2.5 and their B is equal to minus 5.5. Now this question I think is a little confusing in that it uses an A up here, that we end up using a different A over here, but you've just got to make sure you split up your work carefully to avoid that mistake. Okay, let's look at an even more algebraic version of this sort of question, because all good things in maths have more algebra. We're told about the first three terms of an arithmetic sequence, and that means that we're saying that this is where n equals 1, this is where n equals 2, and this is where n equals 3. We're told k is a positive integer, and we need to find the 20th term in the sequence. So what can we tell about this sequence? Well, we know that a is equal to 2, because the first term is equal to 2. And D is kind of the tricky one. The difference between these two is k squared minus 2, and the difference between these two is 5k plus 1 take away k squared. So we don't really have one term for D, but we do know that if the common difference is k squared minus 2 and it's 5k plus 1 minus k squared, those two things must be equal to each other. So we want to equate those. We want to say k squared minus 2 is equal to 5k plus 1 take k squared, and we want to rearrange this into a quadratic formula. So we can get 2k squared minus 5k minus 3. With all good quadratics, we want to factorize it, or you could plug it into your calculator, but I'm going to factorize it. And we'll end up with k minus 3 and 2k plus 1 as our brackets. That'll tell us that k is minus a half, or k is equal to 3. Now this is where we read the question. It says k is a positive integer, so k is not minus a half, k has got to be equal to 3. Okay, great. What you can do from this point is you can now plug that into the first three terms we were given, and we can then work with numbers instead of with algebra. So our actual sequence goes 2, because that's not going to change, then 3 squared, so 9, then 5 times 3 plus 1, so 16. So we can see that the constant difference between these is always 7. So look at our sequence. We've got A equals 2. We've got D equals 7. If we want to find the 20th term in the sequence, we want to find U20. That's equal to A plus 19D. So it's going to be equal to 2 plus 19 times 7, which is going to be 135.